Welcome to Career Guidance Max playlist. Today we are going to start Eigen Values and Eigen Vectors based on problems. So within that I am going to explain first type 1. The type 1 is Non Symmetric Matrices with Non Repeated Eigen Values. So here I taken one problem. I am going to find here Eigen Values and Eigen Vectors of this given matrix. This matrix I am going to consider A. So 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. So is this 3 by 3 matrix? I am going to find first characteristic equation. If it is 3 by 3 matrix means we have to take lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So based on this matrix, I am going to find here 1 by 1. So S1. Here S1 is represent trace of A. S1 is represent trace of A or sum of diagonal element. I am going to add these diagonal elements from this matrix. 11 minus 2 and minus 6. So minus 8 plus 11, I will get S1 is equal to 3. Okay. Next here I am going to find S2. So S2 is equal to, how to find S2? Sum of minus of main diagonal elements. Sum of minus of the main diagonal elements. So based on this diagonal element we have to find minus. So first I am using 11. That means this row and this column you can omit. Remaining values you can write in a determinant form. So that minus 2, minus 5, minus 4, minus 6. I am writing in determinant form. Minus 2, minus 5, minus 4, minus 6. And plus. Next I am using minus 2 diagonal element. So this column and this row I am going to eliminate. Remaining I will write in a determinant form. So that is 11 minus 7 and then 10 minus 6 and plus. Next I am going to take diagonal element minus 6. Based on that, this row and this column you can omit. Remaining value you can write in determinant form. 11 minus 4 and 7 minus 2. And simplify this. Minus 2 into minus 6 plus 12 and minus of minus 4 into minus 5 plus 20 and then this one plus 11 into minus 6 minus 66 and plus 10 into 7 70 minus into minus plus and plus 11 into minus 2 minus 22 and 7 into minus 4 minus 28 already minus, so plus 28 and simplify this. Minus 8 plus 4 and plus 6. I will get S2 equal to 2. So how to find S2? Sum of minus of the main diagonal elements. Based on these diagonal elements we have to find minus. So when I am taking 11 diagonal element now, omit this row and column, you will get minus 2, minus 5, minus 4, minus 6. We written in a determinant form. Then minus 2 means this row and this column you can omit. 11 minus 7, 10 minus 6 you will get. And next diagonal element minus 6 means this row and this column, and 11 minus 4, 7 minus 2 we can write in determinant form. So then we apply determination procedure. How to solve this determination? 2 into 6 minus 12 and plus 12 and minus 20 and minus 66 plus 70 and minus 22 plus 28. When we simplify this term you will get minus 8 plus 4 and plus 6. 10 minus 8 you will get S2 equal to 2. So after that I am going to find S3. S3 equal to determination of A. Here I am writing determination of A matrix and simplify this. 11 of first row, first column omit and remaining you can cross multiply. Minus 2 into minus 6 plus 12 and minus of minus 4 into minus 5 plus 20, and formula minus, here I am taking minus 4 of first row, second column again omit, and 7 minus 6 I am writing minus 42, and then 10 minus 5 I am writing plus 50, and plus minus 7 I am taking this minus 7, and first row third column omit, remaining you can write minus 28, cross multiply minus 28 plus 20, so you will get 11 minus 8, minus into minus plus 4, and minus 42 plus 50, you will get 8, and minus 7, here you will get minus 28 plus 20, you will get minus 8. So simplify this, minus 88 plus 32, and minus into minus plus 7 into 8, 56. So minus 88 and 32 plus 56 plus 88, both will cancel, you will get S3 equal to 0. So this all S1, S2, S3 I am going to substitute in the characteristic equation. The characteristic equation already you know that. What it is? Lambda cube minus S1 lambda square plus S2 lambda and minus S3 equal to 0. Is this our characteristic equation? Here we have to substitute that S1, S2, S3. So S1 is plus 3. So minus 3 lambda square, and S2 plus 2. We can write 2 lambda, and S3 is 0. So you will get lambda cube minus 3 lambda square plus 2 lambda is equal to 0. Is this your characteristic equation? Then we have to find eigenvalue. So from this cubic equation ends with the lambda. So I am taking commonly outside lambda of lambda square minus 3 lambda plus 2 is equal to 0. So I am writing lambda equal to 0, and lambda square minus 3 lambda plus 2 is equal to 0. This quadratic equation I am writing as a linear factor. So take this constant 2. Which two number multiplication gives 2, and which two number adding gives minus 3? Common number we have to take here. So I am taking minus 1 minus 2. Multiply these two, you will get 2. Add these two, you will get minus 3. So that this one I am writing lambda minus 1 lambda minus 2 is equal to 0. So that when equating to 0, you will get lambda equal to 1 and lambda equal to 2. So the eigenvalues are lambda equal to, already will have one value 0, and this one 1 and 2. Is this your eigenvalue? Based on this eigenvalue, we have to find eigenvector. Now I am going to find eigenvector. So the formula is A minus lambda I into capital X is equal to 0. Here A is our given matrix, and lambda into I is identity matrix. The given matrix is 3 by 3 matrix, means we have to take identity matrix also 3, and capital X equal to 3 variable x1, x2, x3. We have to substitute here. The matrix A is 11 minus 4 minus 7, and 7 minus 2 and minus 5, and 10 minus 4 minus 6. Is this A matrix, and minus of lambda into identity matrix 1 0 0 0 1 0 0 0 1. And capital X we can write small x1, x2, x3 is equal to 0. And again I'm writing 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6, and minus of, now you can multiply with this lambda, this matrix. So you'll get lambda 0 0 0 lambda 0 0 0 lambda. x1, x2, x3. Okay. Then now you can subtract both the matrices. 11 minus lambda minus 4 minus 7. There is no element in second matrix. 7 minus 0, 7. Minus 2 minus lambda and minus 5. And 10 minus 4 and minus 6 minus lambda. And x1, x2, x3 is equal to 0. Okay. Now you can multiply both the terms, first matrix row wise, second matrix column wise. You will get equation 11 minus 7 into x1. I am writing 11 minus 7 into x1 and minus 4 into x2. So minus 4 x2 and minus 7 x3. Minus 7 x3. This is first equation. And second equation, again you take 7 x1 and plus minus 2 into minus lambda into x2 and minus 5 x3 is equal to 0. And next one, last one, 10 into x1 minus 4 into x2 plus minus 6 minus lambda into x3 is equal to 0. So which is, consider equation I, A or 1. For your convenience you can take, I will take, this is equation 1. Okay. Now I'm going to substitute lambda values from this equation 1. So I'll take case 1. Case 1 is, I'm going to substitute lambda is equal to 0 in equation 1. So here substitute lambda is equal to 0. 11 minus 0, 11 x1 minus 4 x2 minus 7 x3 is equal to 0, which is equation number 2. And next 7 x1 and plus, here you can substitute lambda is equal to 0, you will get minus 2. So minus 2 x2 and minus 5 x3 is equal to 0, which is equation number 3. So next I am writing 10 x1 minus 4 x2. Here you can substitute lambda is equal to 0, you will get minus 6. Minus 6 x3 is equal to 0, which is equation number 4. When we substituting lambda is equal to 0, I will get 3 different system of linear equation. So from this I'll take any 2. I'm taking equation 2 and 3. I'm going to apply by cross multiplication method. Cross rule or cross multiplication method I'm going to substitute here. So I'm writing x1 divided by is equal to x2 divided by and equal to x3 divided by. So I'm taking equation 2 and 3. First I'm going to find x1. So you can omit x1 coefficient. From this both the equations you can write x2 and x3 coefficients in a determinant form. So minus 4, minus 7, minus 2, minus 5. I'm going to write minus 4, minus 7, minus 2, minus 5 in determinant form. Next I'm going to find x2 value. So you can omit x2 coefficient. Remaining you will have x1 and x3. From this first you can write x3 coefficient, that is minus 7, minus 5. Then you can write x1 coefficient 11, 7. Next I'm going to find x3. So omit x3 coefficient. Remaining you can write x1 and x2 coefficient in determinant form 11, minus 4, 7, minus 2. Okay, and now simplify this. X1 divided by 20 and minus 14 is equal to x2 divided by minus 7 into 7 minus 49 and 11 into 5 minus 55 minus plus 55, and here x3 divided by 11 minus 2 minus 22, 7 minus 4 minus 28, so minus to minus plus 28. So I'm writing x1 divided by 6 and x2 divided by 6 and x3 divided by 6. Here commonly we can divide it by 6. I'll get x1 divided by 1, x2 divided by 1 and x3 divided by 1. So therefore the first eigenvector capital X1 equal to small x1, small x2, small x3, which means you will get capital X1 equal to 1, 1, 1. Is this your first eigenvector? So next I'm going to find second eigenvector. I will write case 2. Put lambda is equal to 1 in equation 1. So here you can substitute lambda is equal to 1. You will get 10x1 minus 4x2 minus 7x3 is equal to 0, which is equation number 5. Then in second equation you can substitute lambda is equal to 1. You will get minus 2 minus 1 minus 3. So 7x1 minus 3x2 minus 5x3 is equal to 0, which is equation number 6. Next 10x1 minus 4x2. Here I am going to substitute lambda is equal to 1. So minus 6 minus 1 minus 7. Minus 7x3 equal to 0, which is equation number 7. So after substituting lambda equal to 1, we will get the system of linear equation. So now we can check whether it is same or not. This here two equations are different, one equations are same. So 5 and 7 are same, sixth one is different. So we need to apply cross rule multiplication method only we have two different equation. Otherwise we cannot able to apply cross rule method here. So I am taking here two different equation. So that is from equation 5 and 6 I am taking, because these two are different equation. So we can able to apply cross rule multiplication method. So now I'll find x1 divided by and x2 and x3. So first I'm going to find x1. x1 means from equation 5 and 6 omit x1 coefficient. Remaining x2 x3 coefficient you can write in determinant form. So you will get 4 minus 7 minus 3 minus 5, write in a determinant form. Next you can find x2. x2 means x2 coefficient you can omit. First you can write x3 coefficient, that is minus 7, minus 5. After that x1 coefficient 10, 7 in determinant form. Next you can omit x3 coefficient and write x1, x2 coefficient in determinant form. 10, minus 4, 7, minus 3. And x1 divided by 4 into minus 5, minus 20. 3 into 7, plus 21. So minus 21 is equal to x2 divided by minus 49. Minus 7 into 7, minus 49. And minus 5 into 10, minus 50. And minus into minus plus 50 is equal to x3 divided by 10 into minus 3, minus 30. And plus 28. Okay. So here in x1 you will have minus 4. So minus 4 into minus 5 plus 20, not minus 20. Okay. And now you can simplify this. x1 divided by plus 20 minus 21 minus 1 is equal to x2 divided by minus 49 plus 50. We can write plus 1 and equal to x3 divided by minus 30 plus 28. We can write minus 2. So therefore the eigenvectors x2 we can write small x1, x2, x3 is equal to, you can substitute the value minus 1, 1, minus 2, or you can multiply by minus, you will get plus 1, minus 1, plus 2. Okay, this is for eigenvector x2. So next I am going to find third eigenvector. So I will take case 3. Put lambda is equal to 2 in equation 1. So apply here lambda is equal to 2. 11 minus 2 will get 9 x1 minus 4 x2 minus 7 x3 is equal to 0, which is equation number 8. Next 7x1, and here you can substitute lambda is equal to 2. Minus 2 minus 2 minus 4 x2 minus 5 x3 is equal to 0. Equation number 9. Next one 10x1 minus 4 x2. Here you can substitute lambda equal to 2. Minus 6 minus 2 minus 8 x3 is equal to 0. Equation number 10. So here this 3 system of linear equation is different. Any two we can take and apply cross rule multiplication method, you will get eigenvector of x3. So I am taking from equation 8 and 9 by cross multiplication method. I'm going to find x1 divided by is equal to x2 and x3. Okay, so I'm taking equation 8 and 9. So first I'm going to find x1. So that means from that two equations I can omit x1 coefficient. Remaining coefficients we can write in a determinant form. So minus 4, minus 7, minus 4, minus 5. And now we can omit x2. And first I'm writing x3 coefficient minus 7, minus 5, then x1 coefficient 9, 7 from the two equations. Next I'm going to find x3. So we can omit x3 from the two equations. You can write the remaining coefficients in a determinant form. 9 minus 4, 7 minus 4. Simplify this. X1 divided by minus 4 into minus 5 plus 20 minus 4 into minus 7 plus 28, here minus, so minus 28 is equal to x2 divided by minus 7 into 7 minus 49 and minus 5 into 9 minus 45, already minus, so plus 45 and equal to x3 divided by 9 into minus 4 minus 36, 7 into minus 4 minus 28, minus into minus plus 28. So I'm writing x1 divided by minus 8, x2 divided by minus 4 and x3 divided by minus 8. So commonly I'm going to divide by minus 4. We will get x1 divided by plus 2, x2 divided by 1, x3 divided by 2. The eigenvector is x3 equal to small x1, x2, x3. We'll write 2, 1, 2. This is your third eigenvector. So finally you can write the solutions. When I am taking eigenvalues lambda equal to 0, I will get eigenvectors x1 equal to 1, 1, 1. When I am taking eigenvalues lambda equal to 1, I will get eigenvector x2 equal to minus 1, 1, minus 2 or 1, minus 1, plus 2. When I am taking eigenvalues lambda equal to 2, I will get the eigenvector x3 is equal to 2, 1, 2. So this is the final answer. Just I will recall what we completed in this video. So I taken one problem from type 1 model. Type 1 is a non-symmetric matrices with non-repeated eigenvalues. That means when we take a transpose of this given matrix not equal, so which is not symmetric matrices, and eigenvalues also not repeated one. Okay, so it is a 3 by 3 matrix, so we have to take the characteristic equation also, lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So from that I'm going to find s1, s2, s3. s1 just we can write a trace of a. Trace of a means nothing but sum of the diagonal element, and s2 we can find based on sum of minus of the main diagonal elements. That means based on diagonal elements you can find the minor values. So that is s2. And s3 already you know that determination of a, you will get that answer. So all those values s1, s2, s3 we have to substitute in our characteristic equation. We will get one equation. If you solve this equation we will get eigenvalues. So here I will get the eigenvalues are lambda equal to 0, 1, 2 when solving that characteristic equation. So after that I am going to find eigenvector based on these eigenvalues. So I am going to substitute these eigenvalues one by one in our formula. So before that I'm going to write the eigenvector form a minus lambda I into x. When I am simplifying this I will get this 3 equation. From this 3 equation I'm going to substitute one by one lambda equal to 0, lambda equal to 1 and lambda equal to 2. When I am substituting lambda equal to 0 I will get these 3 equations. Before going to apply the cross rule multiplication method, you can check this 3 equations. If it is all the 3 equations are same, we cannot able to apply cross rule method. If you want to apply cross rule method means minimum 2 equations should be different. So here I taken 2 and 3 are different equation. I will take the 2 and 3. I applied cross rule method. I will get eigenvector of x1. Again I substituted in the equation 1 eigenvalue 1. I will get again 3 equations. From this I will have 5 and 6 are different equations. So I will apply here cross rule method. Based on that I will get x2 eigenvector. In equation 1, again I am substituting a last eigenvalue, that is 2. I will get 3 different equations. From that I will take any 2 and applying cross rule multiplication method, I will get the answer of eigenvector 3. Okay. Thank you, Pa.